All right, so today we are going to be learning about congruency in triangles. Also how to identify it and a little bit of how to prove it. I want to begin by defining congruence. A lot of y'all already know congruence means equal in measurement. I will also accept equal in shape and size. There's also similarity. Similarity means that they are equal in shape, but they may not necessarily be equal in size. Another word for this is proportional. Proportional. Equal in shape. And you might be saying, well, Miss Hegwood, why don't you just say equal? Well, in geometry, equal means it is equal in size, shape, and location. However, on a graph, if you have two triangles that are equal in shape and size, but they are not on the exact same points, then you have two triangles that are congruent. So let me go ahead and draw an example for you. I have a white triangle here. My red triangle would be congruent to my white triangle because they are over the exact same points. This is equal. If I have two triangles that are equal in size and shape, but not in location, kind of like this, then they are congruent. We got two different points right here. They are not overlapping in any way. Then, here we are. If I have two triangles that look the same, but they are different sizes, then they are similar. All right, now I want to talk about parts of the triangle. Parts of my triangle. Obviously, a triangle is going to have some angles. We all know that it is going to have 3. If you can't remember that, I want you to think about how many wheels a tricycle has. There we go. All right. And then likewise, a triangle is also going to have 1, 2, 3 sides. So thank God we don't have to deal with curves or anything. We're just dealing with sides and angles. Now, you may have noticed I drew a couple lines. This one, and this one. I like to call these lines kitten whiskers. These kitten whiskers show that two sides are congruent to each other. So I know that this side here is equal in measurement to this side here because of my kitten whiskers. But if I had 1, 2, 3 kitten whiskers here and 1, 2 kitten whiskers here, I know this side would not be congruent to this side because my kitten whiskers do not match up. Very similarly, I call these rainbows. They are the little swoops that go in my angles. I have 1 here and 1 here. I know that these angles match up. And likewise, you can have 2 rainbows or 3 rainbows. All right, I want to show you our first theorem. Side, side, side. We know that if our triangles match up in every single side, then they are congruent. And I'm going to show you what I mean by that. Let me break out my highlighter. Okay, I'm going to highlight this side. I know that this side is congruent with this side. Now, they're on separate triangles, but because they have 1 kitten whisker each, I know that these have the same measurement. All right, so I'm going to go ahead and write a side because there is 1 side I know for a fact that has the same measurement. Likewise, here, this one has 2 kitten whiskers, and this side has 2 kitten whiskers. That's another side that I know matches up. Side. there are 3 kitten whiskers here and 3 here. So I know this side matches up with our other side. Side, side, side. If we can show that our triangles are equal in all 3 sides, then we have shown that they are congruent. These triangles are congruent. Let's see one with a side angle side example. Okay? Now I'm dealing with kitten whiskers and rainbows here. Okay? Here is one kitten whisker that lines up with this kitten whisker here. Here is my second kitten whisker, and there are 2 kitten whiskers here as well. Now let me look at my rainbow. I have one rainbow here. Well, here's an angle with another rainbow. So I have a side, and my angle is in the middle. This is very important that my angle is between my sides. Side, angle, side. I want to show you an example where even if we have 2 sides that are congruent to each other, but not necessarily the angle in the middle, it will not necessarily work out. I like to say no donkeys. Angle, side, side. We can check here. I have one angle that is congruent and 2 sides. 1, 2. Even though these triangles look congruent on paper, based on the information that's given to us, we cannot prove that these are congruent. I'm going to show you guys an example later down the road. Here's another example of side, angle, side. And you might be saying, well, Ms. Hegwood, we don't know that we have a congruent angle. And you've been kind of right. It's not telling us that there's a congruent angle, but based on what we're seeing here, we know that there is a vertical angle. You may remember hearing about vertical angles from when we went over parallel lines and transversal angles. Remember, a vertical angle is going to be the angle that is opposite of the intersection. So this angle has a vertical angle of this. Remember, vertical angles are always congruent. Ooh, there we go. Vertical angles are always congruent. So, because I've identified that these 2 angles right here are vertical angles, I know that they are congruent, even if they are not marked. Now, if it helps you out, I definitely recommend marking these 2 angles. All right, let's go ahead and use our highlighter tactic. Okay, here is one kitten whisker, and there's one kitten whisker, so that lines up with side. We know my angle, and then 2 kitten whiskers, 2 kitten whiskers. Side, angle, side. We have proven that these 2 triangles are congruent. Let's remember that my angles are in between my sides. All right, let's move on. Angle, angle, side. Now we have 2 angles here and 1 side. Let's look. All right, I have one rainbow here. Cool. And here's my second rainbow. Awesome. Okay. Oops. Angle. Here is 2 rainbows. And here's another 2 rainbows. That is going to be another angle. And then we have my side. 1 kitten whisker, 1 kitten whisker. Angle, angle, side. Moving on to angle, side, angle. Okay, well I see I have 1 angle here, 1 angle here, and in between them is my side. So let's go ahead and make sure that lines up. Okay, here I have 2 rainbows. Well, here's another 2 rainbows. Awesome. Here is 1 kitten whisker, 1 kitten whisker. Here is 1 rainbow, 1 rainbow. That lines up with angle, side, angle. Because I have my 2 angles over here and my side is in the middle. Perfect. All right, now hypotenuse leg. This is special because it can only work on right triangles. Only work on right triangles. My right triangle is any triangle that has a 90 degree angle. This is going to be an angle that kind of looks like it should be part of a square. This shape right here. And it will usually tell you that it is 90 degrees with this square looking thing right there. Okay, so I have made sure that both of my triangles are right triangles. Awesome. Now I can move on to my hypotenuse and leg. Your hypotenuse is going to be that line that is across from your right angle. So if you were to draw an arrow pointing out of your right angle, you would hit your hypotenuse, okay? Now let's check. My hypotenuse has 1 kitten whisker, okay? And my hypotenuse over here also has 1 kitten whisker. So I know my hypotenuses, they are good to go. I'm going to go ahead and write an H for hypotenuse. They are equal. And then my leg. My leg is just going to be the other sides of the triangle, which we see here, 2 kitten whiskers, 2 kitten whiskers. We're good to go. Hypotenuse leg, awesome. These 2 triangles are set. They are valid. All right. Now, I want to show us what we can't have. Remember, we cannot have angle, side, angle. Here's an example where my angles and my sides line up. So here is my angle that is congruent with this angle, and I measured. My side here is congruent with this side. And my side here is congruent with this side. But did these triangles, do they look congruent? If you said absolutely not, Miss Hegwood, this side is so much different than this side, you would be correct. These triangles are not congruent, and I hope this helps you to remember never to use angle, side, angle, angle, side, side. Because we don't want any donkeys, and angle, side, side will not prove that 2 triangles are congruent. All right? We also don't want any car crashes. A, angle, angle, angle. Angle, angle, angle. These 2 triangles are obviously not congruent. Look at the size difference between these lines. But all of their angles are congruent. You may remember that these 2 triangles are actually similar, but not congruent, or not necessarily congruent. All right? Now, here's what I want from you. I want you to tell me if we know that the triangles are congruent and how. So you're going to tell me if it's side, 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 angle, side, angle, side, angle, or hypotenuse leg. And I'm going to show you an example of how to do that. All right? So let's see. I know these 2 triangles are right triangles. So I know right off the bat that I can only use hypotenuse leg. Let me double check and make sure that my hypotenuse leg is valid in my example right here. Okay, my hypotenuse is going to have 2 kitten whiskers. Okay, let me go over here. Oh, look at that. My hypotenuse also has 2 kitten whiskers. And here, my leg has 1 kitten whisker. My leg here has one kitten whisker too. So I can say, yes, they are congruent because of hypotenuse leg. Hypotenuse leg. All right, now there are 4 for you to do, and I want you to remember, we only know what we are told. So there is a triangle here that looks congruent, but we cannot prove for a fact that it is congruent. Make sure you remember to check for side, 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 angle, angle, side, angle, and hypotenuse leg. If it does not fall in one of those categories, then it is not necessarily congruent. All right, and that's all from me for today. I hope y'all have a good one, and I will see y'all later.